Good morning. Today I'm going to talk about Clojure, NoSQL databases, functional style JavaScript, and how to write HTML5 applications with this. For a short introduction, people who maybe not know me, I'm running a software company since 1999. So my own software company, we are specialized on large internet systems in Germany. And yeah, I started programming in 1983 on the Apple II and worked in Polar research on a VAX, programming on a VAX and on Unix systems, and also did some Lisp at that time as a student and Smalltalk scheme. And then came the bad times where Windows NT was the dominant platform, Unix systems were dying, and so it was a very bad time. I even had to program in VB, Visual Basic, which was the worst experience I ever had. And then the chance was to go to Linux and run my own company on Java and Linux, which Java was very good at that time, was a way to break free from the Windows platform. And so this was actually the stuff that I did. And in the last couple of years, I did mostly like Objective-C stuff, C++, C, Java, Common Lisp, and now lots of Clojure and JavaScript. Yeah, with the deadline, we are also a Hackbox, and I'm also a board member of Hack Forward, which is really nice, exciting times and exciting idea to do some kind of very early investment in cool companies here in Europe. And so what we are actually doing with the deadline is also eat our own dog food. So we are participating as a Hackbox in the Hack Forward community, and I'm also trying to be a board member and support the whole system in this way. Okay, sorry for the colors. Yeah, we had a nice design team from Novi Sad from Serbia who suggested this color theme for our deadline system. Most people said, how can you do this? It looks ugly, but in the end we are quite happy with it because it's really unique. Nobody has color like this, and we really got used, and now we are doing also our presentations like this. So the web is dead. This is what Wired said on I think the last issue on the cover. We all know that more and more people are now accessing the internet via mobile phones, smartphones with internet browsers pre-installed. And by accident, Apple invented the app economy. So it was actually the hackers trying to jailbreak the iPhone and bringing software, external software on this device. And Steve Jobs actually didn't want external software in the device, and so, but because other people were doing it, he invented the App Store. So more and more people are building now specialized apps for these platforms, especially for iPhone and iPad. Android is also yeah, keeping on with this. And the Wired magazine calls these platforms walled gardens, of course, because they're proprietary platforms. And these apps that you're building for these proprietary platforms, which only run on these platforms, are not really on the internet. They're using the internet for networking and transmission of data and all this, but it's not like the traditional websites. And what they think is that we are getting more and more to a world where yeah, systems are working on proprietary platforms and the data is in these walled gardens. So it seems like more and more people are building for these walled gardens. And the question is, do we really have to do this? Do we really need these walled gardens, and will the internet really change in this direction? I think no, because it's really a waste of time to build apps that just run on one platform. So when you build a system that only runs on the iPhone. And on the other hand, it's a waste of time to implement the same application on different platforms. So have one application that you build for the iPhone, then you build the next for Android. So then you have two code bases that you would have to maintain. So we had the same problem actually. We needed a mobile client for iPhone and iPad and for Android. And we are a very small team. And so this would mean in the end that we would have to maintain 3 different clients for these 3 different platforms. And if you take more platforms like BlackBerries and all this, it would even get worse. So, and every feature would then require 3 times the effort because you have to integrate this feature on all platforms. And from the other perspective, this would make us 3 times slower. And we are quite fast now. We are delivering a new release every week. So every Thursday we have a new version. And so we are very fast in the development. But we had problems with the mobile solutions. Our customers were asking for mobile solutions, and we couldn't deliver because we were also very uneasy to have several code bases. So our solution was then to build a unified HTML5 client that runs in all modern web browsers and runs in this way also on the smartphones like iPhone and Android. And as you all know, HTML5 is basically a set of browser APIs and HTML extensions that you can use to build clients that feel more native. And here's a nice info chart on the different APIs that you have, like video, audio, offline storage, drag and drop support, canvas drawing, 2D drawing, cross-document messaging and all this, and which browser supports what. So HTML5 can do much, much more, but we only need a very small part of it for our purposes. So what an HTML5 client is really depends on the type of application you have. So you can build a drawing client or a Photoshop in running in your browser, stuff like this, and then you would need different APIs than we need. So my definition of an HTML5 client for our project is first, the app runs mostly inside the browser, so it's written completely in JavaScript. The apps can be used offline. You can, especially when you have a mobile client, you have to be able to be offline and work with it and later sync the data. And this data syncing is done automatically, so it automatically pushes the changes to the server and get other changes back from the server. It feels more like a native app, but we think that you don't need WIMP interfaces. I'm not quite sure if anybody knows this term. It comes from the time when we had no graphical user interfaces, and this is like Windows icons, menus, and pointer device, and this is like the whole desktop metaphor. And I don't think that you should write desktop metaphor applications in the browser. I think you can do much richer interactions in this. So you can use CSS3, nice transformations and animations, and to just build the interactions that you really need and that support the user. And you support only modern browsers that implement these standards, and you basically don't support IE6 or don't have any fallbacks for older browsers at all. So what parts of HTML5 do we need for this? We need especially client-side storing of data. We need caching of the UI, and optionally you can also use new stylable HTML5 elements and CSS3 media queries to support different resolutions with different user interface definitions in CSS. We are using the local storage API to store the user data locally on the client, and we use a caching API to store the static parts of the UI for the client that you can use it offline. And when you see the deadline, and now you understand why please pardon the colors. When you see this was the deadline, the old style client. It was just a request response style web application. On the server side, we use Google App Engine. For the web part, we use Clojure. We use Clojure as a programming language on top of the App Engine SDK for Java. And the most important stuff that we use is, of course, the data store, which is a distributed key value store. And we use task queues to process data, which I'll come later. On the browser side, we have, of course, JavaScript, and most stuff was done with jQuery at that time. Yeah, so it was like rendering the page on the server, bringing it to the client, and then you had some JavaScript Ajax stuff. So most of the stuff was actually rendered on the server, and there were some Ajax parts for some, answering messages and not having to redraw the whole interface all the time, but it was not very much. So for the server-side rendering, we are using Composure and Hiccup, which is Clojure stuff. And on the next slide, you can see how nice it is to have your application code the HTML, CSS and everything in one place. It's not that we use, like in Java world, you're using template frameworks where you have separated the HTML from your code, and then you have to weave the data into with the templates to generate the HTML. And I think this is the wrong way to do it. It's actually like, since 10 years people are trying to build better and better web frameworks to solve these rendering problems, but in the end I think this is a wrong approach. And what we think is that you just need a special language that you integrate in your own language. So with Clojure you can write special languages, small mini languages that are integrated into your own project, and they can, for example, be used to generate HTML. And it's a good example of how to use multi-methods for UI rendering, and you can see in this example that for Lisp languages you actually don't need web frameworks. So not quite sure if you can see this. So this is actually the part of the code on top that renders to do, and it emits HTML, and you see the CSS classes in the same place. So you have something which is really program code, which in the end generates HTML, and you can see all the CSS classes and all this in one place. So you have everything in one place. You can read through it how it works, and then you have several multi-methods to render different aspects of a to-do. So for example, when you have a completed to-do, it's rendered a little bit differently than a to-do that is not completed. And so with this way, it's very clean code. You don't have extra templates, you have everything in one place, but you still have the separation of the logic and the business logic and the UI. So you still have this, but you just see the stuff in one place. So you see, we are not only strong supporters of the NoSQL movement, which I come to later, but we also suggest a new movement, the no templates movement. So we think it's really good way to not use template languages in this way, but to integrate this more into your application logic with mini languages, which can be done very good with Clojure. There are also approaches in Ruby, and in Java it will be quite difficult, but yeah. We'll see. Too bad that we can't use this on the client side. On the client side we have the JavaScript part in the HTML5 client, and we have to render something there. How we do this? Most people would now say, oh, let's take jQuery. It has now new extensions for HTML5. It's a really good approach, I think. It's a really powerful approach to select DOM nodes and then run functions on the set of nodes that you selected. So it's a really powerful way, and you don't even have to know JavaScript to program with jQuery. So the whole idea is really to execute chain functions on a set of DOM elements, and this is really, really easy. So and really, really powerful, and you have lots of plugins, and you can write plugins for yourself very, very fast. So it's a really good way to use it. But the question is, can you use it for large HTML5 clients? Because in jQuery it has a special way to work with HTML. You have nodes in a DOM tree, you iterate over the tree, you do a selection, you take a set of nodes, then you just have chain function calls. But how to structure this in a larger way? How to bring more structure to this? How different plugins work together? Of course you can do this, but my feeling is, or our feeling is, that this is not actually made for this kind of problem, to build a large client that maybe needs some more structure. And so we think that you end up, and we also tried this, that you end up with lots of code blocks that are not really having a common structure and a common way of work. So for a large client, we think that you need a bit more structure to your code, and what we then tried was Google Clojure library. Google Clojure library is actually what JavaScript is to the JDK. It's a really good standard library for JavaScript, and yeah, it's used in large projects at Google, so it's really mature, and yeah, they're actively working on it. So we gave it a try. It had a much steeper learning curve, but it also provides a very nice package system, a namespace system where you can structure your code, and yeah. By the way, there are lots of comparisons when Google Clojure came out and say, oh, look at this code from jQuery. When you do this in Google Clojure, it's much more code and it looks much more ugly. This is really the case. Of course, jQuery looks very elegant. When you do in 5 lines of code, you can do amazing things. But it's really not a question if you can write 5 lines of amazing, elegant code. The question is, can you write 10,000s of lines of complex code to build a really large client? And when you think about this, you should take a look at more complex examples and write more complex code for yourself to make a really good comparison of this. So I really have to say that 10 years ago I really hated JavaScript. It was really painful. We worked with, we are building large internet systems since over 10 years, and we always received HTML from design companies, and they were like writing JavaScript code which always looked really ugly, and so we actually, everybody hated JavaScript. And it was really difficult to see the beauty of this language when you got bad code. So today, we are very, we really like JavaScript, and in our company we're also endorsing it more and more to write all the JavaScript completely by ourselves and not receiving anything from agencies anymore. But today most people are really trying to structure JavaScript code like Java code, so that you have large and complex object hierarchies, and trying to bring the style that you got from Java to the JavaScript part of your application. And I think this is wrong. Today maybe the JavaScript code looks better, but it gets the same way, it gets really bloated. So Java programs are known to be really bloated. You have to do lots of boilerplate code to get anything done. And what we shouldn't do now is bring this model of programming to JavaScript world, because the language has much more possibilities. So let's stop the bloat. In the deadline, we are already using functional programming on the server side. So of course we wanted to write in the same style on the client side. So what do I mean by functional programming? You can start flame wars on this, but just to make things short, you have first-class functions that are just returning values. So when you put in the same set of parameters, you get the same value back. They're not causing any side effects. You can pass on functions as parameters, so you can have general functions, and you can specialize them by giving them specialized functions as parameters. You can combine functions, so you have functions as building blocks that you can put together, and without causing any side effects most of the time. JavaScript makes all this possible. And with Google Clojure, you also have a library that comes with functions that enables you to work with collections of data in a functional style, so that you're really getting reminded on Lisp and Clojure from parts of the library that they are providing. So for example, when you check Google functions, you see you can compose functions, you have AND and OR functions, so identity functions is really the simple part. When you check Google Array, you have functions like map, reduce, every, filter, flatten, sum, repeat. And these functions are not changing their inputs, so are not working on the collections, so are returning always new collections. So you can really work with them in a functional style. So we started the implementation then with these tool set. And the first we implemented was a key value store API on top of the HTML5 local storage. And because we are used to the way Google App Engine data store works, we implemented a very similar thing on the client side. So we can store arbitrary maps of data, and they're always identified by a key and a kind. Kind is some kind of type maybe. We can say which keys are actually existing in a map. And this key value store on the client side, which we call the event DB, is automatically syncing the data out to the Google data store on the server. So it looks like this, again, the colors. What we have now is we have Google App Engine here accessing the data store, receiving XML HTTP request with JSON, and is notifying the browser when changes are existing on the server side. The pink part here is what we implemented, an auto-syncing, that it's getting notifications, syncing data back and forth, using local storage API to store the stuff, to persist it on the client side. And then we have the event DB sending notifications to the UI when data has changed, changing the data in the UI, re-rendering it, and from the client, from the UI, data is sent to the event DB to be stored, and we first redraw the screen, write it to the local event DB, and the auto-syncing takes care for linking the data back to the server side. So this is a small step for mankind, but actually it was a huge step for us, for the Deadline team, because now we don't have to care about XML HTTP requests anymore. So we just use an API to get data from our local client storage back and forth, and it's automatically synced. So it's really a good way then also to work with the software and to debug it, because you don't have so many maybe competing requests in the background. So cool thing is that throughout the whole Deadline system, we pass out very simple data structures. We have maps of key value pairs, no complex DB mappings like in Java programs with Hibernate and all this. No SQL in the end. We just have the functional operators like filter, map, reduce, and we have easy transformations, so we can take maps, apply functions on them, and transform them into other kind of data structures. And so it's really natural what we are doing there. On the different levels, it looks like this. We have the Google data store which is a distributed key value store. Clojure works with key value structures, and JSON is actually key value structures. So we have so we don't have to transform to different kind of type representations. We just have we get almost the same stuff from the data store which we end up in the client. And so in this case, a little bit like functional programming is, from this perspective, the opposite of object-oriented programming. We have really simple data structures, but we try to write powerful functional operators that work on these data structures. And yeah, of course, we try to have no state and try to have as few state management as we can. Well, of course, you need some state somewhere, especially for the UI, of course. When you try to we try to write functional code as much as possible, but when you have to render the UI, of course you have some state in the UI. And so how you do that? So how do you render the user interface on the client side? In this case, object orientation can be very useful, like in widget libraries, like you maybe know from Qt or GTK. No, not GTK is not maybe a good example, but yeah, all widget libraries in the end have some kind of object-oriented structure where you have a component or a container and the component can be a button or it can be a text area and all this. So you have kind of yeah, over the last years, over the last 20 years maybe, there's a common structure how you build stuff like this. And you can, so Google Clojure also comes with such a library, and you can extend it like with any other widget library. You can extend your own components, write your own components. And so maybe when you have to encapsulate state, then you maybe write a component. And but when you're rendering the client-side UI, we are in the end using Google Clojure templates, which is a templating library in JavaScript. And you can also integrate your components in there. And this looks approximately like this. You have very simple templates in a very simple template language. And in these templates, you can define your HTML. You can call other templates. For example, this is a template to render the to-do list. So it's really not more code like this. And then you call other templates like completed to-do. And the completed to-do is then generated from these different parts. Also other templates that you can call. And these are generated to JavaScript functions and can be treated as function calls. So each template is actually JavaScript functions, and you pass the data to be rendered as a parameter. So this looks then like this. This is also one function from the deadline code, render to-do list. We have some debugging up there, and then we have here a map function which takes a list of to-dos, and we call a function to prepare the to-dos for rendering. We add some data, and then we have a new collection of to-dos, and then we get the list container from the UI API, and then we render it by calling just the template name and passing the data as parameters, and we have internationalization messages, and then we send it out that it's going to be rendered by the system. So it's really clean code that we have here, and it's really good to maintain. So just a reminder, we did this all because we want to run the system on mobile phones, on web browsers, on your desktop and all this. So this code actually also runs on Android phones, on iPhones and all this. Of course, we generate different user interfaces for different platforms. So compare this with the work you would have to do when you write proprietary clients for each platform. And I can tell you this is really much more fun than maintaining different code bases at the same time. So now we have a nice HTML5 client. So we can use it on several devices. You can use it offline and sync later. Actually, we didn't publish it now, so we want to publish the mobile clients end of October. But when you're working on different devices, sharing data with different people, then you come to a point where you maybe have concurrent modifications of the same data. And of course, when you have a centralized web server and you just send data back and forth, this is much easier to maintain. But when people work offline and later sync your data, you maybe run into problems that different people change the same set of data. So what you actually need is a data model that is able to store versions of your user data that you can manage conflicts when updating data. Relational databases are actually not very well suited for data versioning. If you ever try to version a large graph of entities, they're distributed over several tables. It really gets a mess. People are copying large graphs and having extra tables that you can do this. This is really, relational databases are not made for these kind of problems. So good luck when you try to do this. We are really happy that we have a schema-free database, NoSQL key value store. And no matter what Michael Stonebreaker, the database guru, says, we think that this is the way you should work with modern applications. Our solution is almost a functional data structure that we have. We store every change on the to-do as an operation on this entity. So, and we store all these operations with the data, so we can redo and undo everything that you did to a to-do. And so we can restore every state change, and we can also resolve conflicts. Some stuff you need the user, of course, too, so not everything can be done automatically. But to give you an example, you can see this in the history when you go into the deadline and click on history. Here I created a to-do. Then I changed the text. I added 3 words. So the to-do text was first, this is a to-do. I changed this to this is more than a to-do, and we have a diffing of the text here. Green means this was added to the text, and it also stores the date and time and who did this. And then I changed something. I changed this to life is more important than a to-do. So we threw out the word this and added the word life, and so you can see the diffing here. And we could also, of course, add an undo operations, which we also maybe provide someday. But we have the structure to really do this from the beginning. So we, the first version of the deadline already had a data structure like this. So the schema-free databases like Google Data Store really helps you, a lot to implement a model like this, and to make and keep the code really elegant. A dynamic functional programming language like Clojure really helps here too. So we don't have to generate complex object graphs and all this. Really pass around simple data structures. On the server side, we are trying to, of course, we store all the data, we take care for security and all this, but what we're also trying is to make modern applications more intelligent. So normally applications are structured like this. You as a user yourself, you have to find out what you have to do with all the data. You can maybe have functions, but the application is not helping yourself to focus on the right data, on the right functionality. So what we did with the deadline is we integrated a rule-based expert system. We don't use any statistical learning or something else like this now, because we wanted to focus on bringing, for example, when you know a very good project manager or maybe a very good secretary, or they know how to get things done. They know when to ask you and remind you, and when it is maybe annoying for you. And we try to extract these rules from good secretaries and good project managers first, to have something which we can build on, where the system can behave in a way for like 80% of the tasks, which are normally just reminding people, giving information that something was done or wasn't done. So just the tedious part of project management, we try to automate this with a deadline and using a rule-based expert system for this. So we use it for decision support in the end, and what we want to do is to provide the right information to the right person at the right time, in real time, so that you're in a project management situation, that you're always optimally informed about the status quo. So we have lots of rules. When you have lots of rules and you don't want to make decisions in cascading if then else clauses, this gets really difficult to test. So expert system, what we use is a Clojure-based implementation. We implemented this ourselves in our company, of a classical production system like OPS5 or Clips, which you maybe know. And here's an example of the code of 2 rules from the rule base. You see the syntax is really almost identical to OPS5 or Clips, and these are the rules to put a to-do into resubmission and to send a resubmission message. So yeah, when you see this maybe on the internet later, you can go through the code. Maybe yeah, we are also thinking to open source this and yeah, to provide this to a larger programmer audience. So on the server side, we're actually processing large data sets. We are generating facts from the user data. We enrich the data. We call this short-term memory. And then we run this data through our expert system shell. And this generates, in the end, actions for the user based on these rules that we have. And you see these actions in these yellow messages box on top of the deadline when you're using it. And we try to improve the rules for all situations. And we like you to give us feedback what we else could do better, of course, for your situations. And again, Clojure really helps us to implement stuff like this. We have a Lisp-like syntax. We can really use old computer science book from the AI times and really use the old books to implement this stuff. Yeah, conclusion now is, for me, so when you want to start a company, it's very likely that you have to build for mobile platforms, like Eric Schmidt said on this Barcelona event this year. Google says we build always now mobile first. So yeah, and so instead of building several proprietary platforms for proprietary platforms like iPhone and so on, it's much better to use HTML5 as an open standard. This saves money and time. It's much more fun. And my impression is also, if you want to be successful, stay away from relational databases. They're really also in larger applications. They cause problems. They're always a single point of problem in the end. It's very difficult to distribute them, even if Michael Stoneberger says something different. Maybe you have to buy really expensive Oracle servers, which you maybe don't want anyway. Yeah, and so there are lots of schema-free databases now out there. And there you can build versioning data structures, which you maybe need anyway when you have several concurrent users accessing data and changing the data. So we also suggest becoming a JavaScript master, use a mature library, because your HTML client will become big and complex, and maintaining large JavaScript code bases is a really new problem space, and there's almost no books, no really good books about JavaScript, so you have to do lots of learning here, but you should focus on having clean code and structure the stuff very well. We suggest start thinking a functional way. Not everything is an object. Don't try to bring your Java skills to JavaScript. Try to do something new. And of course, have fun. Starting a company can be so much fun, and of course you should use the tools that you really like, because you will spend lots of time with them. And maybe also sign up for Hack Forward. I know maybe this will be also put on the internet, so if you like to work with a group of nice and funny people here every 3 months, sitting together and exchanging ideas and building a community, helping each other. So this is really accelerating the work you are doing, because you're not working alone. You have friends and a group around you. And of course, I'd love to see more Clojure hackers building their dreams. I know there are thousands of people out there loving Clojure, writing programs, but they're not able to use them, for example, in their company, because they maybe have to use C++ or have to use Java, but they would love to build something with Clojure, because they love functional programs, they love Clojure. And maybe this is an opportunity for you to build your dreams, use Clojure, and maybe make a big business out of this. So, thank you very much.